everybody, or good brunch. I don't know what the local term is for something so close to 12. Thanks for coming out. My name is Udi Dahan. I'm going to be spending the next hour and a bit talking to you guys about this topic of loosely coupled orchestration. For those of you who don't know much about me, I've been working as a consultant for many years, working with companies pretty much in every sector imaginable, helping them solve their problems of big, tightly coupled balls of mud, which, quite frankly, is probably not very different from the problems that you guys are facing on a day-to-day basis. The difference is, as an external consultant that's flying in, somehow the act of getting on a plane gives me more credibility. So I can come to a company and just chat with you guys that are on the front line, like, what's the problem going on here? Like, well, there's this, and there's this, and there's this. Great. And then the next day, I'm talking to management, like, and you've got these problems, dude. Like, wow, you're so good. You've been here, like, not even a day, and you've nailed every single one of our problems to the letter. And so what should we do? And the previous day, I said, what do you guys think we should do? Well, we should really do this. We should just parrot the exact same things. You know, you're right. We should do that. But there's a certain act of a company spending a lot of money to bring somebody from far away that makes them, psychologically more likely to actually take the advice. See, as employees, you guys are already paid for it. They're not paying any extra for your advice, therefore it's very easy to ignore. But when you're paying a lot to bring somebody from far away, psychologically it's difficult to not act on that advice, because ultimately what that means is that you kind of threw that money away. So sometimes the most effective way of getting something done is just bringing somebody else from outside to say what you've always been saying. And I know it sucks, and I know it's unfair, but it's better than tilting at windmills. Let's put it that way. So a lot of my success as a consultant over the years has really just been kind of listening to the people that are actually doing the work, and hearing about the problems and the recommendations, and then ultimately getting credit for it, which is in many cases undeserved. But it's worked pretty well for me so far. During that period of time, one of the common things that I saw lots of companies struggling with is, even when they got to the point that they're saying, okay, we want to introduce some kind of messaging, we realize that it's a good way of decoupling the system. Messaging technology, though it's been around, I'd say, arguably for decades, the act of putting it in requires a fairly high level of technical competence that unless you configure things exactly the right way in the right places, you end up with dangerous problems in production. So things look like they're working okay in development and test, but when you go live, things fail in unpredictable ways. So we're going to be talking about a lot of those sorts of problems now, as well as, for those of you who aren't necessarily convinced, the advantages and also some of the pushback that you might get when trying to promote these ideas of a more loosely coupled way of building a system. And then towards the end, I'm going to show you things like tooling that I've been working on for the past several years to try to make building these sorts of systems easier and to keep better control of a large code base. We have lots of team members that are working on it, that maybe not everybody's an expert. So starting with sort of at the beginning, I have this title slide, which depending on how you look at it, could be very nice and part of the romantic period, versus the what are you doing in going to show community at a development conference. But the principle of building a loosely coupled system in many cases is I see modeled after the quote-unquote real world, where there is no God up in the heavens, at least that we know of, that is instructing every single person in every single action to perform something at a specific point in time, getting a response from here and saying, okay, now you go do something over there. Rather, it's a more, there's a sort of spark of life that's given to this human sociological system with certain basic laws of physics, if you will. And then it's kind of, okay, go do your thing. And then we've got these actors that each one is operating largely independent of the others. We don't sort of have a situation where if somebody doesn't give you a response, then you're not able to do anything at all. And these sorts of systems have, over the span of the, if we just look at human society, it's kind of been fairly robust for the past 1,000 years. Even though we've had wars and mass genocides and all sorts of really bad things that happen to the system, we're still here, right? It's kind of hard to say the same thing for the code bases that we've been working on. Sometimes they last, maybe a good 3 to 5 years is sort of a nice average before developers kind of get so sick of it that, well, tell me if you've ever made this statement, that you get this new business requirement for your system, and you say, it would be faster to write the system from scratch than to implement this feature on the existing code base. Who said that before? Okay, show of hands, be honest. Okay, a lot of you. Now, we don't always get away with this, okay? But sooner or later, the technical debt ends up catching up to the company, and whether they like it or not, there's this major rewrite. So it might be 5 years after the original project started, sometimes 7 years, sometimes 10 years is kind of like, oh my God, wow. Where if you kind of look at long-lived code bases, we're counting them in years. If it kind of scratches the mark of the decade, that's impressive. But it's not just about the inherent technological evolution. For instance, who would have, 5 years ago, who would have expected that JavaScript would become a popular language, right? Imagine somebody comes to you and said, you might not know this, but there are going to be a whole new set of developer conferences that all they do is they talk about JavaScript. And you'd be like, get out of here. And COBOL too, right? But here we are. Okay, so it's, whether the technology was dead / almost dead / on the way out, or now it's new, a lot of the principles about how we design systems don't fundamentally change when, whether we're using a strongly typed or loosely typed language. Yes, the code that you write is different, but the interpersonal semantics and how teams work together and source control, a lot of those things are still kind of moving forward. And this idea of loose coupling, it's also been around for a very long time. But I want to anchor this a little bit in some history so that we can understand that on the flip side of loose coupling, there are some concerns that are raised. So starting in the beginning, kind of like the creation. In the beginning, there was chaos. And for us, it was go-to statements. Now, personally, when I learned programming using GW Basic, I thought that go-tos were amazing. You had your line numbers, 10, 20, 30, 40, right? You always got to make sure that you leave some space. You can always introduce some code afterwards. And then you could very simply, go to 35, go to 33. So it worked great, single developer working by themselves in a small code base. But as you want to have more people working on the code base, it didn't work. Structured programming came along, so that's it. No more go-tos from now on. Only, you have one method that calls other methods, and that way you can have some control. But when the idea of object-oriented programming came out, and a lot of times you kind of look at it, there's this hindsight bias, if you will, that we assume that because something was successful, because it became popular, because now we're all doing object-oriented programming, / we're using object-oriented programming languages, that at the time it must have been obvious to everybody what a good idea this was, and that's why it became popular. But at the time when object-oriented programming came along, there were a lot of naysayers from the structured programming world that said, this is dangerous, this is risky. When I'm working on a system built in C, when I call a method, I know exactly which code is going to be executed. When I'm working in C++ and I call a method on an object, because of all that crazy polymorphism thing that you've got going on, I don't know whether the code that's going to be executed is the method on the base class where it's implemented, or you've done an override in some subclass that I don't even know about. And now different, how could you possibly build a stable system when you don't know which code is going to be executed when you're calling. And there were serious concerns about that. Now, of course, here we are, several decades later. We're over that. But also when the idea of event-driven programming came along, I'm not even talking about asynchronous, network-based, all of that crazy. Just a very basic concept of a pointer to a function. It was that same element of, how could you possibly understand what the code base is doing, especially if it's not just sort of a pointer to a function, but a proper event where you're just raising an event. And your code doesn't know even how many different objects there are that are going to respond to this or what they're doing. So there was this deep concern that we would end up creating a worse mess of spaghetti than what we had with GoTos. Because with GoTos, at least you could see where you were going to. When you're raising an event, it's kind of like, I don't know. It could go somewhere, it could go to multiple somewheres, it could go to nowhere. So how do you build a system that way? And I'd say the fundamental, let's call it misattribution error that we've got in software is that we often look at things from the perspective of, well, if I was the only programmer, then, and I could keep the entire code base in my head, then structured programming is great. But the problem, or let's call it the march of progress, if you will, is forcing us to solve ever larger problems than what a single programmer is able to do by themselves. Ergo, we need multiple developers working at the same time, and for them to be productive, we need to make them, going back to this picture over here, as autonomous as possible. We want developers to be able to implement features on their own and integrate it in such a way that changing a bit of code over here does not break something over there. And that's the general, if you look, it doesn't really matter which specific programming language. All of them are moving in the same sort of direction of saying, how can we make teams more effective? And along the way, we might be sacrificing what a single developer might experience, because ultimately that's how we solve today's problems better. So just to make sure that you understand, even today when I introduce the company to messaging, like, well, we've kind of made our peace with this object-oriented thing, and events and callbacks, well, we kind of use that at a very basic level for UI-related stuff. So, user clicks a button, and we get a callback from the button. Like, that's just about as much event-driven programming as in the mainstream. When you say, hey, look, I want you to fire and forget a message to a queue, and off of that queue, you're going to have an event that gets published. You're going to have 3 different subscribers, and they're running in parallel with each other. There's this sense of, oh my God, this is insane. How could I keep control of my system with this many moving parts that are independent from each other? It's the same sort of reaction that has happened every single shift that's been going on in the history of programming. So when you get that reaction, one of the best ways that I found in responding to this is, well, it may seem very natural for you to do object-oriented polymorphism and that kind of stuff today, but I mean, if you look at it, it follows the exact same thing. How do you keep in control? And in many cases, the answer is, well, today we've got debuggers that allow us to step through the code and see what's going on. And we don't spend months and months writing code without ever executing it. We write a little bit of code, then we run it, we debug it, we step through the code, and we get a sense of what the system's doing. That allows us to see what's happening at runtime in the actual execution without necessarily at coding time knowing, okay, I'm calling object A or object B. So it's these tight loops of feedback between coding, running, debugging, getting feedback, and then iterating on that again, that has allowed us through time to more effectively have more people doing this type of loosely coupled programming than before. Okay? So a big part of it is tooling. Unfortunately, one of the areas that's always, well, I wouldn't say always, but for a very long time has been lacking in a very large subset of the messaging infrastructure world is tooling. From the actual, let's call it runtime or feature set, it does what it's supposed to do. The tooling around that, the debug experience, is really rather horrific. And that's an area that we're going to be talking about later on, about all sorts of strategies that I've applied with my clients around trying to solve that. And for you to take some of these ideas, some of them are very simple and easy to do, that make life so much easier when building these types of systems. So let's again, count us back in history to make sure that we have the complete picture. So some of the challenges of any sort of software architecture is that most software architecture decisions are taken at the beginning of a project, okay? And the issue with taking these decisions at the beginning of a project is that your code base is tiny. You're thinking, oh, I gotta implement a feature, so I just implement a simple little screen and have it talking to a database. And then the next day, I add another screen and I might pull out a little common type of domain entity to them. And then a little bit later on, I add another screen and I have a little bit of interaction over there. So by looking at the system, and it's really funny when you talk to business stakeholders, fundamentally the system is very simple. Have you heard that statement before? I say, fundamentally the system is very simple. We've got users, they need to use the system, and we can store some data in the database. That's it. Well, yeah, you've just described Facebook. And you've just described a trivial iPhone app. And you've just described every system on the planet. In other words, you've given absolutely no detail at all about why this system exists. But you're saying, fundamentally, it's a simple system, which is a way of me communicating to you, I don't have a very large budget. So you better get with the program and start churning out features, really, really quickly. Not because fundamentally it's a simple system. Fundamentally, I don't have a lot of money, but I expect you to work wonders, okay? And then we start, and then a lot of times, this is one of the things that I actually take some issue with the Agile movement, is, or I say how Agile is practiced in a lot of companies. There is a great, so Kent Beck, one of the fathers of, the father of XP, and therefore one of the fathers of Agile, talks a lot about the concept of a system metaphor, okay? You have to get a good sense of the whole thing. You don't have to have detailed requirements on every single thing, but you need to have a good sense of what it is, how complex it's going to be, and what are the rules and the nature of the complexity. And a lot of the ways that Agile is practiced is, oh no, forget about that. Tell us this first iteration what you want us to work on, what's the highest business value. And then we make a bunch of decisions and we implement that in a nice agile iterative way. And then the next iteration comes along. And the thing is, when you start a project, the beginning of a project is always great because you don't have any legacy code to deal with. So you're making all sorts of decisions about how the architecture should be built, should be structured, without having a complete understanding of just how big and complex is the thing that we're going to build. And you're kind of nailing down all of the important decisions before you have enough context. And then, in iteration 4, it gets a little bit more complex, and in iteration 5, it gets even more complex. And before you know it, right, without any advance warning, one day you come into the office and you've got a big ball of mud. And it's kind of hard to put your finger on that moment. Was it iteration 6? Was it iteration 7? But somewhere along the way, this problem kind of got intractable all of a sudden. And we kind of feel like the architectural decisions that we made at the beginning are, they're not really working as well as we thought. And every incremental feature that we're building is harder and harder. Even if you're doing TDD and BDD and DDD and every single other DD on the planet, the problem is that if you don't have enough context and you're making decisions in this type of, well, keep it simple, you aren't going to need it. That's a very micro optimization type of mentality, where your complexity starts to grow exponentially, and then once you're in trouble, you can't really rewind the clock. So sometimes you actually need to go back, and that's one of the things that messaging does. Messaging does not start out this simple, okay? It says, in order to introduce messaging, your threshold, your barrier of the amount of things that you need to set up earlier on is actually a bit higher. And that's one of the reasons when talking to agile organizations, they're like, you aren't going to need a big design up front. I say, no, you don't understand. What we're trying to design for is what the system is going to be like 6 months from now, a year from now. We know we need loose coupling. We know we need teams to be able to work effectively. The fact that we can build the first feature in 2 days might not be the most important thing. If along the way, the 5th feature takes 2 weeks, and the 10th feature takes 2 months, and the 20th feature takes 2 years. Okay? What we're trying to do is get to a model where features of a similar size should take a similar amount of time. We want a nice flat graph, if you want, of velocity. We want sustainable pace. But sustainable pace means thinking and designing for the whole system problem, as opposed to, but wouldn't it be faster if we just did this? And a lot of times people conflate the two terms with agile. Doing this is agile because we'll be done faster. Okay? No. Okay? Agile, one of the maxims is the simplest thing that could possibly work. Who's heard that term from? The simplest thing that could possibly work? Okay, great. That is very different from the first stupid thing that comes to mind. Okay? But in many cases, we kind of say, but that's agile, because it'll be done tomorrow. No, that's quick and dirty programming. Okay? So don't necessarily conflate that. And I call this the good old days. It was that way all along. It was, in essence, development without a methodology. It's just kind of code happens, and we do these sort of micro-optimizations, and then we create a mess, and then, oh crap. Now, occasionally when I come to these companies, I say, what you really need to do is, divide this thing up and introduce some asynchronous messaging in there. Kind of look at me like I'm crazy. Look, we can barely keep control of our code base as is. And now you're telling us that bits and pieces are going to be running in parallel with each other, asynchronous from each other. How could that possibly make things better? There's this, we can barely keep all 4 wheels on the road as it is now. Now you're saying each wheel is going to be autonomous and do its own thing. It feels, for somebody who already feels out of control and overwhelmed, to introduce these types of things, they don't connect the dots. All they're seeing is it takes the problems that we're in and just gives me, if you're going to make the system parallel into 5 moving parts, you've just made my problem 5 times bigger, rather than making it 5 times smaller. So that's the sense that I got from a lot of people when giving these ideas. It's this, no, that's insane, that's wrong. It can't work. Now, sometimes, again, that whole issue of how do you convince them? You can try kind of leaning on your own credibility and say, believe me, I know what I'm doing. Okay? Sometimes you get away with that. Occasionally, this happens when you get a new CIO in the company. So a change in management is always a good excuse to change, however you've been doing things. Because new management always likes to change things, right? Now, if this doesn't work because you've been in the company long enough, you can try sort of a variation of this, of Udi said so. Right? Well, I was at this talk and Udi said so, and it sounded really good, so let's do that. Please, don't use this. Okay? Don't get me in trouble. I have this every once in a while. Somebody sends me an email and says, look, we're on this project, we're in a lot of trouble. Some idiot in the company was at one of your talks last year and started introducing these ideas, and they created a god-awful mess. So now, not only don't we know what to do, we're entirely dependent on you, Udi, because he was applying all of your principles, and nobody else understands your principles. So we need you specifically to come in and solve this problem. Like, well, I'm sorry, I'm busy. No, you don't understand. We need you tomorrow. Okay, so be careful with this. Don't get me in trouble this way. Back to more practical matters of how do we go about introducing this? So first of all, I want to give you an idea of what loosely coupled orchestration might look like in a fairly trivial retail domain. And then I'm going to point out some benefits and then some things that you need to watch out for and keep in mind as you are building these sorts of systems. Because making things more loosely coupled, there's the overhead. I wouldn't say it's a performance overhead. In general, it makes things faster. But there's a cognitive overhead. There are problems that you didn't used to have before, you didn't think you had before, that now need to be dealt with more explicitly. So let's start with some basic pub-sub, publish-subscribe communication at a logical level. Or we've got a user that's performing some action against a service over here. And while historically we might have had a big e-commerce system that is validating the order and recalculating the total and charging the customer's card and allocating inventory and et cetera, one big, gigantic synchronous process thing. And now we say, do we really need to do all of that synchronously? And the answer to that is actually not a technical answer. You do need to have a domain expert in there. So if I look at, say, the Amazon.com, or Amazon as a company, they've got my credit card on file, okay? They've charged my card like, I don't know, a couple hundred times before. They know this card is good, right? I'm now buying a book that costs $20. I've easily spent several $1,000s with them in the past. What is the risk? In other words, if we were to perform the action of billing the customer asynchronously with respect to the act of placing the order, meaning the user places their order, we do really sort of basic validation type checks, but then we say, you know what? I think this is good. Let's give the user immediate feedback. The book's on the way, even before we've charged the card. Why? Because we know this customer's order history. We know they purchased so much from us in the past, there's no risk. And on the really weird off chance that, my wallet got stolen last week at an airport, and as a result of that, the credit card that they have on file is now blocked. And well, what should we do then? That's an exceptional business case, as opposed to the regular one. They say, look, 99% of the orders, we can now process them much faster. We can reduce load on the website by saying, hey, you got it, rather than blocking the user saying, wait, leaving HTTP connections open for a long period of time, just in case. So one of the things that's important when thinking about introducing messaging and asynchronous communication, it's not just let's swap out HTTP web services for some queuing system. It's actually about restructuring the business processes, and you do need somebody who understands the business to be able to help you find the right points in time. You can say, actually, yeah, that's fun. We can publish an event and do the rest of this asynchronously. And oh, by the way, now that means that if we make a change over here, the likelihood of a change in this code, breaking any code over there, is vastly decreased. Why? Because now we've introduced this temporal decoupling, the decoupling on the dimension of time, as well as it's not so request response anymore. Like, hey, you're doing this. Well, what should happen if the billing fails? Well, I had this happen to me. I get an email from Amazon saying, look, sorry, we have a problem charging your card. Please go back to the website and give us an alternate form of payment. Okay? So the order itself is not invalidated. It's sitting there. It's a valid order, it just hasn't been charged yet. And only when this bit resolves itself, by me providing different payment information, will this bit of code publish its own event and say, okay, we've charged the customer, now we can go about shipping the products. So again, in this sort of model, we've broken up the business process to be more asynchronous, to have explicit steps along the way. But as a part of this, it's not just about saying, okay, here we have request response, let's stick some messaging in there. It's about really working with domain experts to find the right places to cut things. And that, together with asynchronous communication, together with the messaging and all of the other benefits that it provides, is what gives us looser coupling at a code level. It gives us more logical coupling in the system. Now, we're going to talk more about this type of thing, about why you might want to have this shipping service also subscribe to the order accepted event. But number one thing I want you to take away from this slide is that introducing loosely coupled messaging patterns with all the benefits they provide, there are business ramifications. They usually result in good things for the business. I don't want to say that these are bad ramifications. They're good things, but it's not always something that you as a developer can come up with by yourself. So, and along the way, sometimes the rules get a little bit more interesting. So we have rules over here that says, well, it's only for customers that have placed more than 10 orders that we're going to do this asynchronously. For everybody else, new customers, we want to do it synchronously. That's fine. You can have both models at play. So far, so good with me? Yes? All right. Now, before talking too much more about the pub sub, because there's a lot of interesting stuff, I'm going to talk about potentially using messaging patterns on this link as well. And later I'm going to show you some demos and show you how simple and easy it is. One of the conceptual challenges with building an asynchronous type of environment is that, imagine the case that we're not talking about placing an order, but say changing the customer's address, okay? Simple operation. What happens if the user changes their address and then changes their address again? So they're performing two actions, one after the other. Now, in a traditional request-response type model, where the user is blocked from performing the next operation until they receive positive confirmation on the last one, so it's change address. Did it work? Yes. Okay, you want to change the address again? Fine. Everything remains in order because the user is blocked at every step of the way. By introducing an async type model, you just says change address, and you fire that off and allow the user to perform another action. When they click change address again, there actually is a possibility that the second invocation might be processed before the first. That's a problem you don't have in a traditional REST type of API invocation. You introduce messaging, you introduce async. Everything runs much faster, you get fantastic scalability, but you have to understand, well, what if things are processed out of order? It could happen. Now the solutions here are very simple. Okay, that's one of the things that I like about messaging is that for every problem there's always a very simple solution. But you do need to know this is the set of problems, these are the set of principles that you need to go through when designing the system. So this element of, for example, changing an address. If you know that the user can submit one change address after another in a non-blocking fashion, then you want to make sure that either the messages are processed in order, right, so one before two, or that if you first end up processing version number 2, that when version 1 comes in, you know to discard that. So ultimately what that means is a very simple thing that you want your client to provide some sort of version number or sequence number or timestamp, whatever you want to call it, a header on a message that says, I performed this at this point in time, a way of indicating this was first and that was second. And then in the logic that you have over here, that you should also persist. Okay, I performed action number 12. And if I receive action 13, okay, great, I perform action 13. If on the other hand, I process action 12, and I have registered in my database the last action, or the version number of this entity is 12, and now I get a command that's telling me this is version number 11, I can safely discard that. But this is logic that you have to write. And that's one of the important things. Introducing messaging often means I'm going to write some more code. Now, and I get pushback on this. And people say, well, why would we want to, you're telling us we're going to have to write more code. You know, how is that going to help our project be done faster? Because we're so far behind anyway. The thing that a lot of these loosely coupled patterns do is it's ultimately an element of trade-offs, okay? And the way that I look at it is very simple. Messaging and other loosely coupled patterns solve a very expensive problem for me, or a problem that I don't have a lot of control over. How do I deal with a big ball of mud, okay? Making a big ball of mud maintainable is really hard. Making a big ball of mud scalable is really hard. It takes a huge amount of effort to do that. And it's non-linear. It's not like every single one takes the same amount of effort. It's a huge problem, and I've never found a technique that kind of gets me to the point that I still have a big ball of mud, and the next time I need to perform an operation, it's already scalable. So in essence, what these patterns do is they say, look, instead of having one monolithic code base, you're going to have, in this case, 3 smaller code bases, where a changeover here is not going to break that. So we've improved maintainability. Because all of these things are running in parallel with each other, we've improved scalability. In other words, we've solved the big, hairy problems of software. And we've replaced them with smaller problems of well, you need to store a version number and check it. I'm like, yeah, okay, 4 lines of code, I'll write it. Like, no, that's not enough. You got to do this other business rule over here. If the billing fails, you need to send an email. Like, dude, I've sent email before. It's not that hard. So that's in essence what we're doing. We're trading off big, hard problems in software in return for getting smaller problems in the form of new rules to write. Like, yeah, I know how to do that. I've done that before. I solved that over here, and I'm done. You unit test it, and off you go. So, all things get, but it's more code, like, yes, but it's more clean code in a separate section of the code that won't break anything else. I'm perfectly happy writing a little bit more of that sort of code, knowing that I'm not going to break anything else, rather than going back in here and saying, well, you don't have to write that code. You're just stuck with the big ball of mud that you had before. Now all you need to do is make it scalable and maintainable. I don't know how to do that. I've been spending a lot of time on it. I still don't know how to keep something a big ball of mud and solve those problems along the way. So that's what we're doing, and I want you to understand, it means more code. It means more business rules. But in the grander scheme of things, you come out far ahead because you're trading in complexity that is difficult to handle for smaller amounts of complexity that are easier to handle. So it's not absolutely free, but you do come out ahead. Yes, question?
I guess you're showing an extreme case here, but if people were coding against interfaces and have injecting implementation, it wouldn't be that difficult then to evolve the system to use messaging, right? Maybe yes, you have to move things around a little bit, but.
So with regards to, let's say, a system which is not necessarily asynchronous, publish, subscribe, that kind of stuff, your comment might be, as long as I coded it well. In other words, I'm using a lot of the solid principles, so single responsibility, interface segregation, all that kind of stuff. Does that mean that I'll end up with a big ball of mud? Now, that's a difficult one for me to answer, primarily because I've seen people try to apply those sorts of principles, but it is, or in my experience, it is more difficult, and I'm going to talk about some of the additional patterns that support this in a minute. Saying, well, if I base my architecture around a request-response type of model, even if I create interfaces rather than coupling directly to the concrete class, the amount of data that I'm passing around, because I'm designed to expect a response, is going to be larger than if I'm designed in such a way where I don't expect a response. So it's not just the fact that I'm using interfaces or that I'm doing TDD or those sorts of things. It's designing the system in such a way that I don't expect a response. And that requires me to partition my logic in different ways and to partition my data in different ways. That ends up meaning that there is less logical coupling, not because it's, not by virtue of it being synchronous versus asynchronous, but by virtue of the fact that I'm not expecting a response. But in order to do that, ultimately, this leads me to additional patterns. That, messaging is one part of it, but if I really want to have a scalable system, then, and I don't want a lot of coupling, I want to avoid having some big master database here in the middle that everything is reading and writing from, right? So that's always very dangerous. We know that, it's better to call a method on an object explicitly as opposed to, well, I'll write something in the database and then then later on, you'll look it up by ID and then you'll get the data. And then if I change the schema, I've broken your code, right? So it is preferable to have explicit coupling versus that type of implicit coupling. Messaging, what we do is kind of take that to the next level, say, well, instead of having a single master database for everything, looking at each one of these services as having its own little part of the database, a subset of the data that it needs. And there's all sorts of interesting patterns we can't really get into in the context right now, but one of them, if you're interested in, is the idea of a composite user interface. So instead of thinking of this being the only UI that the user can interact with, imagine if your user interface was a collection of widgets. That the user's shopping cart is in a widget over here, but when the user wants to provide their credit card information, that widget is actually sitting over here. So the user is actually typing their credit card information into here, which is stored in this local database. And as a result of that, we don't have to pass credit card information from there to there. When it comes time for the user to provide their shipping address, they type that into a widget that belongs over here. So the entire context of, is there a shipping address? What does a shipping address look like? How do you validate it? Is entirely local over here. And as a result of that, we don't have to pass shipping addresses and billing addresses and credit card information across these messages, which, in addition to them being one way, not needing a response, now they contain much less data. Okay? So it's all of these techniques together. Publish subscribe is one of them. Each of them having their own database is another part of them. Having a composite UI where each piece collects its own part of the puzzle. So composite UIs, take a look at frameworks like Angular. You know that not all the code needs to exist in one place. The fact that these are different services, just think of them as kind of different JavaScript fragments that are loaded into the browser from different directories. That's really all that there is to it. It's nothing fancy. And voila, you have a composite UI. So all these types of things together mean less data needs to be passed around. You have much more stable message contracts. Lots of good things happen to your system, no question about it. But again, that first step to get something working is a little bit higher. So doing this is more complicated than this. When your entire UI is just one monolithic UI. When everything that needs to get passed in needs to be collected and passed directly through. You can get this working really quickly. You want to go to PubSub with Angular and that kind of stuff, where was I over here? Saying, wait, now we need to know Angular. Now we need to have a publish subscribe framework. Now we need to have more than one database schema. Now it's like, whoa, this is now my bar to entry before I go anywhere. But once I'm here, every new feature doesn't really add very much more complexity. Okay? So let's talk a little bit about the infrastructure side of things, because again, sometimes I get questions about it. You say, well, doing everything asynchronously, how do we handle when things fail? So in this example, let's say I'm talking to the external billing web service, the credit card payment authorization gateway thing. And in the middle of doing that, something bad happens. So first of all, we're going to talk about this in the case of, say, your code talking to a database, but the same principles apply. So when you're using a queuing infrastructure, it's not the only thing that you need. There is some transaction management that we're going to talk about over here that is going to make the likelihood of a failure lower and your ability to recover from a failure much better. So let's say a message comes in, as we said, whether it's an order accepted event, or whatever. And now we want to process this. So pulling the message off of a queue, simple code, there are tons of samples online for the different types of queuing system. But what you want to have happen is that any logic, say that you're invoking against a database, so your core business logic over here, that's operating on all sorts of tables in your database, that if something bad happens in the middle of this process, where it could be that the database server crashes, it could be that your server crashes, it could be any number of things, that not only will any changes that you make to the database roll back, because databases tend to do that pretty well by themselves. The most important thing is that this message rolls back to the queue, because it's really important not to lose that. Why is it important not to lose that? Because we don't have a client that is waiting for a response. The client sent me this message and now it's doing other things. So it can't handle an error type of condition the way that a regular web service invocation would. So when I get this, I'm really responsible. That's part of building an autonomous type unit. Self-governing self-control is going to say, you better be responsible. When I send you something and it arrives there, there's something important in there. You can't just flake out whenever you feel like it. So even if, again, database goes down, your code goes down, you want to make sure that this thing can roll back. Now again, I wouldn't say that this is true about every single type of thing in your system. If you're talking about a very basic query, then who cares if it gets lost? But if we're talking about meaningful business events or commands that are coming from the user, well, yeah, I don't want to lose that. So you want this type of, this DTC object is a distributed transaction coordinator. Something that coordinates the work that you're doing against a database as a transactional resource and a message as a transactional resource. Now, distributed transactions have gotten a really bad name over the past several years. It's kind of like they never, ever, ever do distributed transactions. They're slow, they're bad, they're ugly, and they drown kittens. It's just like, never, ever, ever. But when you think about it, beyond kind of saying, distributed transaction is bad, the number of machines involved in the transaction isn't necessarily any greater than if this were an HTTP call coming to a regular app server that opens up a transaction and talks to a database. Same number of machines that are doing the transaction. Okay, so all that we're talking about is using a different transactional resource on the same machine so that we get higher reliability. But a lot of times when they get into these discussions, like, oh no, we shouldn't do distributed transactions, they're slow. Like, well, let's assume that they were slow. I don't think that they're nearly as slow as people make them out to be. I've done lots of tests to prove it. Let's assume that they were actually slow. So think of your most prized possession, okay? For a business, it's their business data. For you personally, it might be your children. I'm saying, well, I'm going to drive your kids to school. But instead of all of those seat belts and airbags and brakes, all of those things make the car really slow. I'm going to take all of them out, and I'm going to drive your kids that way. So no boosters, no child safety seats, none of that. And this is how I'm going to drive your most precious possession from one place to another. And you're saying, are you sure? Yes, it'll be really fast. Dude, you're not making me feel any better. Safety first, speed second, right? And that's a problem that we have in the programmer community as a whole, because performance is so easy to measure. It's something that we optimize for. Oh, I don't want that crappy MSMQ. It can only perform 1,500 messages per second. You can use RabbitMQ, and they can do 30,000 messages per second. Like, okay, how many messages per second do you need in your system? Like, well, I've only got like 1,000 users today, so we might be doing like 2 or 3 messages per second, and at peak it might go up to 10. So what's the problem? Well, if we need to scale really, really big, it would be better for on RabbitMQ. Like, well, just hold your horses here. You have plenty of headroom with what you got now. Maybe you shouldn't be thinking so much about performance and not thinking about anything else. Performance is easy to measure, so we optimize for it. Reliability is very difficult to measure. How do developers measure reliability? They download a sample, they run it on their machine. Works. Or download a sample, run it on their machine. Didn't work. Piece of crap. Right? If it works right away, then it works. And if it doesn't work right away, it's a piece of crap. That's how we make decisions. Now let's go measure performance, right? So please, 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 safety first. Make sure you're not losing data. You're going to want a queuing system that can solve these sorts of problems for you. Now, if you don't have that, for example, RabbitMQ doesn't support distributed transactions this way. MSMQ does. ActiveMQ says that it does, but it only does when you do native Java. Okay, so if you're using the Java client of ActiveMQ, then you're performing XA transactions, say, against an Oracle. That's going to work great for you. If you're using ActiveMQ and you're on .NET, the .NET client does not actually work with Distributed Transaction Coordinator, even though the documentation says that it does. And you could lose messages. So yeah, I wish I could tell you that the situation is really solid out there. It's not. Okay? It's kind of this Wild West of sometimes it looks like everything's working on your machine, and then you put it into production and messages get lost. And every once in a while I kind of say, when I say that, but it's really fast, is the response. I think, losing messages really quickly is not a good thing. Okay? If anything, I want you to lose messages slowly. Like, oh no, that's eventual consistency. There's an important part of eventual consistency. It means given enough time, the system will become consistent. If you have lost data, you are eventually inconsistent, not eventually consistent. Okay? So you want to make sure that you're testing for this kind of stuff, make sure that it's taken care of. But a lot of the various types of bus technologies out there that are setting up the transactions correctly, make sure that there's also a certain element of retry logic built in, because once the message is back in the queue, say, all right, now let's try this again. Maybe all that we had over here was a deadlock, right? So something really small and quick and easy. So if we just try again, it'll solve itself. In some cases, maybe if we try and try again, eventually we're kind of like, well, it's been 5 days, and the message still hasn't succeeded. It doesn't look like it's going to succeed. We'll talk about these scenarios. But again, it's the kind of thing that you don't really think about with web services. So think about your average web service call. Like, okay, I invoke a web service, and if everything goes great, wonderful. If it doesn't go great, I might get an error message that comes back to me, or I might get a timeout. So what do I do as a client where I get a timeout, right? If the server that I'm talking to crashes. Well, so who here has had an invocation to a web service in production timeout once, at least once? Okay, yes, everybody. What did you do about it besides logging it? Who retries? Okay, I've got maybe half the hands that went up before. So you're doing a retry. Do you know that the thing that you're talking to is actually the fact that it timed out that it didn't perform the operation the first time? Could it be that it completed the work and that just the response didn't arrive? So you need to have some deduplication, also known as idempotence, on the other side. So even if you retry over here, you kind of have to add a little bit of deduplication logic over there. So for all those of you that do the retries, who include some deduplication logic on the other side to make sure that things don't end up being processed twice? Okay, getting kind of half the hands. Now imagine that it's not just one call, but again you're doing one web service that calls 3 other web services, and each of those calls several others. You have a sort of a bigger orchestration going on. How do you manage all of these retries across all of these different partners? It becomes really complex really quickly. Okay? So most of the time, what companies end up doing, sorry, what programmers end up doing, in an agile kind of way, say, well, I don't think this is providing a whole lot of business value. So we'll put that in the backlog, and we'll build some other features in the meantime. So we tend to take a preference for building new features as opposed to making the features that have actually already been built reliable. And then, of course, the system goes live, and then, oh yeah, we really should have done something about that. Well, if the users complain, then we'll know it's a problem. Like the system's quietly losing data, and yeah, nobody's complained yet. Well, if they complained, how would we hear about it? Are we, waiting for it to blow up over Twitter and Facebook before we actually make the system reliable? Like, would you bank at the bank that you're actually building the software for is the question. So, yeah, solving these sorts of things, it's not difficult, but there are certain things you need to keep in mind. Deserialization failures, for example, doesn't make sense to retry. If you have a bug that throws an exception. As I mentioned before, in a synchronous architecture, any type of problem is visible back to the client, but usually the client can't really do anything about it. When we're talking about an asynchronous architecture, that's when we can start doing something a little bit more interesting. So, for example, by having the client be disconnected with respect to this, we can take all of the messages that failed their processing and put them in a different queue. Say, so we had a deserialization error, let's put that in this queue over here for an administrator to look at later on. Or, we had an exception while processing this message, even after we retried it 10 times over. Let's just put this off to the side. So we don't have to lose something, even if we can't process it. Because, deserialization failures often occur when we deploy vNext of our system to production, right? We've got some vCurrent clients talking to vNext server, and then deserialization problems occur. So the good news is that we don't lose that data. It ends up in some other queue, which then we can handle later on. Again, client is not exposed to it, which is a good thing, right? You don't want to have this in this case where you deployed a new version to production and then users start seeing errors all over the place. What that does mean is, from the end user's perspective, ignorance is bliss, right? I clicked the button, the system said, we got it. But in reality, it could be that that message is in the middle of a retry loop, hasn't actually been done yet, and 5 minutes later we'll end up in the error loop. And the user thinking, wow, this was a great user experience. I clicked the button, 2 seconds later, they said, you got it. And off I go off doing other things. And it was never actually done. So sometimes the best way of giving your users a good user experience is to blatantly lie to them. Okay? But saying, we said we did it, does not mean that we actually did it in that moment. It's that the whole eventual consistency thing. We want there to be a certain bit of, well, can we fix this later on? And part of that is, now gets into the tooling side of things. This is where, again, a lot of messaging systems are like, well, we might have the concept of a poison ladder queue, but there often isn't very good monitoring around that. So think of it from, Star Trek, Next Generation or otherwise. Just think about the number of episodes that the Starship Enterprise would have just blown itself to bits if it wasn't for Scotty or Geordi LaForge, taking care of it. I can't hold it, Captain. But they do. You do need to have the tooling behind the scenes. See, the system's doing all of this crazy asynchronous, loosely coupled stuff, but we do need to have this exception catching that when things go wrong, we'll know about it. So some sort of dashboard, this is something that I built, very simple and trivial, that every time that a message fails, meaning ends up in an error queue, we have a tiny little process that takes a message out of the error queue, puts it in a little database, and then we have this nice little web UI on top of it that shows an administrator, hey, a message failed. Come over here and take a look before the user starts complaining. And again, because when we're talking about messaging, we can take over the entire body of the message. So we can actually show the user, this was the actual JSON payload that failed. Here was the exception stack trace. So this endpoint over here failed processing this specific message. Here's the stack trace. The reason that we can hold on to the stack trace is that this code over here, in essence, surrounds your code. Okay, it takes the message out of the queue and invokes your code, and as a result can catch any exceptions that you throw. And as a result of that, it can take the stack trace together with the original message in the queue, bundle that up and pass that off somewhere else. Now, this is very simple code to write, okay? So first of all, the code that I wrote, it has a name, it's called End Service Bus if you're interested in it. But the principles are really simple. Just saying, well, if you're doing some sort of messaging, write a little wrapper around the messaging library, and when it invokes your business code, have it catch any exceptions. And if all of your retries fail, take the original message, stick the exception stack trace in a header, and pop that over to a separate queue. Okay, it's like 20 lines of code. It's not really that hard. And then, on the flip side of it, as I mentioned over here, have a little something that's taking that, putting that in a database, and providing some basic visualization. Another thing that's important when you're talking about monitoring is heartbeats. Okay? Is everything up and running? Again, in the synchronous architecture, if things aren't running, the user's going to see it. Right? You're going to try to connect to something and you're going to get a timeout exception, a connection refused exception. Things blow up in very end-user visible ways when we're talking about synchronous architectures. When we talk about async, we're going to want something that's kind of looking at all of your moving parts and saying, okay, I've received notifications, I've got 3 independent services, and they're reporting every once in a while a message saying, I'm online, I'm good. So that way, if anything goes down, then this little thing say, hey, over here, administrator, come fix this. Again, because the end user is not impacted. That's back to that whole ignorance is bliss thing for your end users. But your admins now have to kind of keep a better watch over your system. So it's not hard to build this stuff, but once it's there, often you'll see that the resistance that you get from introducing asynchronous, loosely coupled type of communication. Well, okay, if you have this, then we feel more in control, so you can go and do all of your loosely coupled stuff. However, if you didn't have this, there's the sense that everything's loosely coupled, but we're out of control. If there's a problem, how do I know that there's a problem? Right? The end user doesn't see the problem, it kind of quietly fails. People don't like that. So it's a little bit of tooling around the edges that can really go a long way. Another bit that's very useful and helpful is auditing, sometimes known as journaling, which ultimately means that as the messages flow through your system, what you do is you kind of create a copy of those messages and you forward that to a separate queue. Again, almost all of the queuing systems out there provide this out of the box. Okay? So number one, turn it on. Okay, it's usually off by default. Turn it on. Number two, what's really important, is don't leave that in the queues. Okay, because otherwise what you end up with is sort of one queue in your system that's growing and growing and growing and growing and growing. Eventually you'll run out of space. Okay? And then your whole system will crash because the queuing system won't accept any more messages. So you're going to want something that is feeding off of that audit queue and dumping it into some sort of long-term storage. Again, it's not rocket science. All this stuff is fairly simple. Now, the advantage of having this sort of audit built in, especially if you add a little bit more information in the message header, so that, let's go back a couple of slides over here. So for example, when the first message is placed, every message has an ID. What you can and you should do when thinking about auditing and journaling is to provide an additional header of your own. Sometimes these are called a conversation ID. So when a message comes in from a client, put a conversation ID in the header. And then when this event is published, propagate the conversation ID into it as well. And then when this event is published, piggyback that same conversation ID on. Because in essence, what you're doing is you're leaving a trail of breadcrumbs in your audit log so that you can actually say, whatever happened here was a result of this specific message, which was a result of that specific message, which was a result of that specific one. And it makes it possible to create a visualization. And yeah, visualization can be something not very complex like this. Okay, the message started over here, and then we got these two events that came out of it. And as a result of that event, we got this event, and out of that, we got that. Very simple to build. Again, you just take this information out of your audit queue, dump it in a database, a little bit of visualization and graphing, and when you can show this, whether it's to developers, administrators, business stakeholders, say, even though everything is loosely coupled, autonomous, scalable, here's a picture of what's going on. So this is the expected flow. And if an event is missing, we can see it. It's visible. Now maybe that message is stuck in an error queue, and then we have that little red thing that's popping up saying, hey, look, this thing failed over here. So just a little bit, sprinkle a little bit of headers over here and a little bit extra over there, some visualization. These are not really complex tools to write. But the impact that they have towards how developers and administrators and business stakeholders look at your architectural decisions is very significant, or has been very significant in my experience. So being able to say, yeah, but this is what ran. And the more moving parts you have, the more important it is to be able to have this sort of visualization. And it's not complex. Okay? This code is very simple to write, and again, it's often on the side for everything else. And incidentally, again, if you like what you're seeing, we've built a bunch of this stuff. You can go online. It's all hosted on GitHub, so you can see how we built it. Okay? It's not rocket science. So even if you're not using a service bus, you're not on .NET, take a look at this stuff. Say, oh, okay, I could build something like that. And the cost of doing that versus the cost of dealing with a big ball of mud where everything is tightly coupled, there's really no comparison. So before I wrap this up, because I still got some more time, I want to show you one more piece of this puzzle, okay? And that is a design time environment that we've been working on that kind of makes it easier to build a system that has all of these things that we're talking about over here. So what we've been trying to do, and it's kind of been a good amount of effort. So everything that I've shown you so far, simple, easy to build by yourself. Okay? This last bit that I'm going to show you is actually much more time consuming to build. But hopefully can sort of get you into that state of mind as to why you might want it. So ultimately what I wanted to do is I wanted to have a way where I could take sort of a picture that I draw on a whiteboard and say, this is the message flow that I want in my system. And I want to have that sort of Captain Picard experience of make it so, right? I think a lot of us kind of want that in life, the nice big button, right? Whether it's in the IDE or on your computer, that make it so. And then, lots of minions kind of run around and do whatever they need to do, and it just happens. Okay. Now the thing is that it's possible to do this, but it's a whole lot more work. So I want to show you this type of environment that we've created to give you a sense of just how quick and easy it can be to build a message-based solution. So I'm going to be using .NET and Visual Studio because ultimately the tooling around Microsoft is a little bit, well, I like it. And the extensions that we've done to Visual Studio have this thing over here around that service bus, so we can create an in-service bus type system. And I'm going to build what you saw over here from scratch, and then you're going to sort of get a sense of that experience of what it means to actually build a message-driven system. Because a lot of times there's the sense of, oh my God, it's really complex and there's lots of stuff to set up. There can be, but we're trying to work on making that better. So, Here I'm going to build an Amazon type solution. I'm going to call this Amazon 3 because I think this is the third time that I've built this, and then it won't conflict with anything else. So it's doing also, let me yank this thing down so that I've got a little bit more width, because the width is important here. So what this environment allows me to do is kind of express what I want built rather than focusing on the how I want to build. So for example, in this case, I would like to have a new endpoint, and this is going to be a ASP/MVC website, and I'm going to call this thing my front end endpoint. So here it generates the project for me and sets up all of the references and dependency injection, and you can see NuGet is kind of pulling down all sorts of magic as this is happening. And then ultimately it's going to give me a nice little icon saying, okay, here's your front end, what would you like to do with it? And there it is. Okay, well what I'd like to do is I would like to send a command. And this is going to be a part of the sales service, and I'm going to call this submit order. So as I do this, it says, oh, okay, great. Here, let me create that message for you. And there's a component over there that is processing that message. It's called a submit order processor. Currently, it's not deployed to any place. So what I'm going to do is say, I want a backend process for this. I'm going to deploy this thing to a new endpoint, call this backend. And we have this host process type, which is at debug time, it's a simple console application. And in production, you can install it as a Windows service. Or you can also do self-hosting, but let's not talk too long about all of the options. And again, it's taking the code, as you can imagine, it's generating a bunch of code and configuration behind the scenes. But one of the things that it's doing is it's generating all of the routing configuration that goes down into my queuing environment, saying, now I know that you have 2 queues over there, and I need to set up the routing to send that from one place to another. And incidentally, one of the nice things about Service Bus is that if you want, over the properties over here, you can say, let me zoom in over here, instead of having MSMQ as a transport, what I'd like to do is I'd like to choose ActiveMQ or RabbitMQ or SQL Server or Azure Queues or Azure Service Bus, because ultimately, why would my make it so experience need to change whether the system's running on bronze pipes or lead pipes or aluminum pipes? Just make it so, damn it, right? And of course, we've got these things like the error queue and the audit queue and all that kind of stuff. So it allows me to focus in on doing what I want to do without getting bogged down in the details. So now let's do the rest of this really quickly. So I'm going to publish an event that we saw before, and that's called order accepted. And from order accepted, we're going to add a subscriber in the billing service. And then it generates a component for that. And then I'm going to deploy the billing component to another backend. So let's call this, say, backend 2. Again, all of the routing is being set. I'm allowed to say what I want to have happen. And ultimately, I can afterwards go into each of these message types and say, well, let's actually put some real business data in my submit order message. And this is a proper object, a POCO, POJO, whatever you want to call it. And over here, I'm going to stick in, say, an order number, just so that we have something to deal with. I can put any amount of information that I want in here. And in the order accepted event, I'll also do a similar type of thing. So I'll have the order number because I want to see that propagating throughout the entire system. And now I'll peek into the code over here of my submit order processor. And here it's saying, okay, I'm handling the submit order message. And now what I can do, for example, is I can talk about how to propagate data from the incoming message to the outgoing message by implementing a method. Well, I actually have to compile this first, sorry. So the compilation sometimes does take a little bit, but give it a second because, well, it's doing a lot. But again, when you compare this to having to learn the API of a specific queuing system, as opposed to focusing on what you want built, it's kind of no comparison. So here I've got a method called configure order accepted. It provides me the incoming submit order message. And then in here I can say, I want the outgoing messages order number to be equal to the incoming messages order number. And I'm done. It's already doing the publish for me behind the scenes. So all I'm talking about here, propagate the data this way, and off we go. Okay? So let's add just a little bit more because I want to get shipping in here as well. So let's create another subscriber, and there's shipping, and we'll deploy shipping to another backend. I hope you're getting the sense of just focus on what you want done, just like you would if you were drawing on a whiteboard. Okay? So say what you want done, where you want it put, arrange things as you want. And at this point in time, I'm not yet going to go to the element of, why not? It's so quick. Let's publish an event here. We'll call this order build. And we'll have shipping subscribe to that. And we'll deploy that to backend 3. Okay? And now we've pretty much set up what we've got over here. How long was that? It was about 10 minutes. Okay? Well, that's impressive that only if it runs, right? Like drag and drop, but it doesn't work. So now what we're going to do is we're going to run this whole thing. Oh, I forgot to actually transfer in the order build event an order number, so we'll add that last tiny piece here in just a second. But again, even as you're looking at this, remember that we've got this other thing down here, which afterwards is going to show us what actually ran. Okay? So let's do the order build event and add the order number in there. And we'll operate on the code over here really quickly. And like before, that doesn't even feel like coding, right? Once you got resharp, everything like all enter. Not typing anymore, right? So message order number equals incoming message order number. And now let's run this puppy. Okay? So it springs to life. You saw all of those console applications popping up. Those are all of our hosts. This is the thing that's going to show us the message flow that we saw before. And here we have our front end of DC. It also has this little test messages thing that gets built in because it's so annoying to actually test what you've just built that what it does is it creates this type of property grid for every single message that comes out of this endpoint. So you can say, I would like to trigger this with an order number called 765. Send that message across. And we see that message start to propagate. Here, sales has received submit order. And here we've got billing has received order accepted. And over here we see that shipping has received both order accepted and order billed. And all of this is happening in an asynchronous, reliable, magical type of way to help prove that I'm not pulling the wool over your eyes. What I'm going to do is I'm going to kill the shipping backend process, okay? And we're going to send a bunch of other order numbers over here, okay? And again, you see front end is not blocked, it's sending messages. This back end is receiving those. The second back end is receiving those events. And then when the back end number 3, where is it? When back end 3 comes back to life, debug, start new instance, then all the messages are sitting in its queue, waiting for it to finish its processing, and then, finishes processing those events. So all of the reliability, scalability, all of the great stuff that you expect from a queuing system is handled for you. You don't have to deal with any of that crap. It just sort of works. Now the second bit, as I mentioned, is this diagram over here. So this app springs to life when you're debugging the first one. And what we do is we do a nice little trick that when we invoke the system, we pass in a session ID as a kind of additional conversation ID, if you will. So all messages that flow through the system, in addition to the regular conversation ID, they have a debug session ID, because it could be that on my machine I've been running 50 different debug sessions. I only want to see the one that I'm working on right now. And it, in that way, keeps me fully in sync, okay? So in this model, I can always say, okay, show me the body of these messages, and here is order number 765. And if there were any errors, we would see them over here. We also have performance information that tells me, okay, this had 122 milliseconds of processing time, and its delivery time was 74 milliseconds. So it gives me a whole lot of useful information, whether it's me as a developer wondering how fast this thing is running, or actually in production, where's the problem in my system? So it's very nice, simple, and easy to build a system this way. But again, I don't want you to get too hung up on this specific set of tools. I want you to take away from this the idea of the fact that even though the code itself is loosely coupled, that you can see every single component from this picture. I make a change over here, that's isolated, that's separate code, and that the code up over here or over there doesn't compile directly against that. And that any change that I make to it, therefore, is not going to break anything else. And also, if you include composite UI patterns, and no, we haven't yet built the magical Angular JS integration. Once people start seeing this, they're like, more. It's kind of, all of a sudden, the appetite of what becomes possible. Because, okay, we're working on it. It's going to take some time. This has taken quite a bit of time to build. But again, the focus being, when a new developer joins your team, and instead of seeing, a big, gigantic solution structure saying, okay, here's the code base. And like, okay, how do I figure out what does what? Well, we drew something on a whiteboard once, but it's, and we even took a picture of it. And we even are able to find the picture of it, right? We're doing well. The only problem is, that was 3 months ago. That was 6 months ago. Now the system's changed. So whatever documentation we have is out of sync. This sort of thing keeps in sync with your code. So when somebody's new coming up and saying, well, yeah, I can traverse the code base by looking through it over here, it's equally easy to traverse it by ultimately looking at the live documentation. So it's much faster for a new developer to understand, okay, this is my part of the world, this is what I'm interacting with, these messages are what I care about, let's focus in on here. It's much faster for them to actually understand what's going on. So, that's number one. Number two, when it comes time to talk to business stakeholders, or for those of you that are consultants or contractors or anything, one of the features that we've been asked for by consultants is the export to JPEG feature. Okay? Do I really need to make a screenshot of this and then take that out somewhere else? Can't you just export it to a JPEG? Yes. Oh, and incidentally, could you put my logo on the top? Is the feature that is immediately asked together with that. They're in our backlog, okay? No promises on when that's going to be built. But it is useful to have this element of a good way of communicating with less technical stakeholders as to how the system hangs together. And I guess what I want you to imagine, if you will, is a proper developer setup, not a screen that's 1024 by 768, okay? But a proper rig where you've got this diagram on one monitor, and you've got this diagram on the second monitor, and you have these things in sync as you're debugging the system, and every time that you're stepping through, you're seeing, okay, this is the next message that pops up, and here's the next message that pops up. And again, if anything fails, then it gets retried and ultimately gets shown here in orange, and we've got the production monitoring tool. And it's, you know, I've been working on in Service Bus for about 8 or 9 years, and it's only recently that we've kind of added these tools. And now when I talk to teams about using messaging as an infrastructure, and they look at these tools, there's a visible sense of, you know, all of the pushback of we feel out of control kind of drops away. It's just by having graphical visualization of what I want done, what has actually happened, makes them feel in control. And as a result of that, makes them willing to build these more loosely coupled, message-driven type systems. And then you can go back to having conversations in the form of, you know, let's get a domain expert in here and talk about what's the right way that we divide up a business process and allocate responsibilities, and what extra little rules do we need to write over here. Those conversations tend to go much more smoothly when people feel like, I can see this when I look at my code. This is not just an abstract concept. The visualizations are there. Then they can go back, it's interesting. Once it's there, then they're like, oh, okay, then I don't need to worry about that anymore. Now let's talk about what rules we need to build over here. So it's a certain psychological barrier that once you cross it, they're like, oh yeah, this loose coupling thing, I'm totally with you. But up until that point, they're totally against you. So some of it, as I mentioned before, the monitoring type bit, not rocket science, the bit of the visualization towards the end thing over here, again, just a little bit of headers that you put on top of things. Again, it takes some time to build this, but it's totally doable. Okay, this is like maybe a week of work for a senior developer, you know, not really crazy type stuff. And you know, even if you don't provide the design time coolness that I showed you, it goes a long way to getting people comfortable with the idea. And then the benefits of actually having a loosely coupled system start to really be felt. And you're not really in that model of, okay, it's been 3 years, it's been 5 years, I can't wait to rewrite the system. Occasionally, this is something that I would say is an advantage. People go, well, this is big design up front, or we don't have time, we're agile, the business requires us to run experiments really quick. I said, look, you can do that in this model. The business says, look, you know, throw me together a quick prototype of something. Say, sure, I create a new service, subscribe to the events of the existing ones, quick and dirty, hack out a new piece of code over here. Say, is this what you meant? No, not quite, I kind of wanted this other thing. And again, I kind of just hack that code a little bit more. Is this what you meant? So I can very quickly iterate in a new section of code that is synced up by these events to the rest of the system. So the business says, yes, that's exactly what I want. And then I can say, okay, great, now we know what the requirements are. And I can take the code that I wrote, throw that away, write it again properly, using domain-driven design and test-driven development and all of those great things, and have a properly designed thing. Again, without destabilizing anything else. So the loose coupling is not only helpful for the real production code, it's also very good for running these quick little experiments that the business is saying, oh, try like this or try like that, or I'm not sure, give me some A/B testing, okay? Loose coupling helps in those regards, but it doesn't help on day zero of the project, okay? There is some initial setup to do. What we've tried to do with the tooling that I showed you in the last 20 minutes is to take that initial setup and really squish that down as much as possible so that you can sit down with the stakeholder and kind of say, okay, here we are 30 minutes later, here's the thing that I was talking about, and it works. More importantly, it works reliably. All of the things that we mentioned over here, you don't have to be afraid of taking it into production and losing messages. But, again, caveat emptor, you want to be careful about the queuing system that you select underneath. Although we support them all, for example, RabbitMQ does not support the distributed transactions type thing. In our next major release, not the one that's coming out now, we're going to be wrapping the transaction management in Rabbit in a new way so that you'll be able to run this pretty much exactly the same way without having to do any deduplication or craziness in your business code over here. Without the same way, RabbitMQ, MSMQ, ActiveMQ the same. Okay. So currently, anybody that's running on RabbitMQ, is anybody running on RabbitMQ? Okay, yeah, some of you. So a couple things to keep in mind. You need to make sure that your code does deduplication / idempotence. Okay. Before you think that that's a trivial thing to do, it's not. Okay. Second thing, make sure you've got publisher confirms turned on. Okay. All those who raised their hands on RabbitMQ, raise them again. Okay. So have you heard of this concept of publisher confirms? Not all the hands are going up. It's a very important concept. When your code over here, say you receive a message, you're going to do something against your database and you're publishing an event. Okay? What happens is the RabbitMQ client, by default, does not actually talk to the broker directly when you ask to publish the message. So what can happen is you receive the message from the queue, you talk to the database, you invoke the RabbitMQ client, say I'd like to publish a message, you act the first message from the queue, you think you're consistent, so you commit, and as luck would have it, your server crashes at exactly that moment. The problem is that default behavior that when you say to send a message via Rabbit, that message can actually be sitting in the RabbitMQ client library on your machine and not have been sent. So you end up with a situation, going back to the screen, where order accepted arrives here. Your logic here does everything that it needs to do correctly, but because of an inopportune crash, this message does not get published. Okay? And as a result of that, shipping doesn't occur. Those messages, they just disappear into the mist. Okay? Make sure you have publisher confirms turned on. What that means is every time you ask the RabbitMQ client to send a message, it will actually synchronously communicate with the broker and make sure you got the message, right? That's really important. Otherwise, this whole pub sub loosely coupled thing, it just kind of falls apart. Okay? So again, that's something that we've set up by ourselves, and in Service Bus, when we're wrapping RabbitMQ, we make sure to turn publisher confirms on. But for those of you that are using it directly, make sure you do that. Okay? There are lots of little dials and knobs and things in queuing systems that if you're using them directly and not via something like in Service Bus, you really need to understand them. Otherwise, they can look like, well, it works on my machine, and it works on the test environment, but still it's liable for losing messages. So I hope I've given you a sense of what it would be like to build a loosely coupled orchestration type system, the types of tools that you want to have around you, the types of patterns that are underlying those tools, and more importantly, I hope I've given you the sense that, you know, we can do this. Let's give it a try. Not, hey, let's take our next, biggest, most mission-critical system and build it entirely this way. I don't recommend that. You don't jump from 0 to 100. Take some small steps along the way. Take some things that are already asynchronous in your system. For example, sending email. Who needs to send email in their system? Yes. The problem with sending email is SMTP servers are fickle. If you're integrating with a web service that sends email for you, again, if that service is offline, you can be hosed. If your service crashes, emails might not get sent out. Introduce a little bit of messaging over there. Start small. Get it in there. Let administrators get comfortable with it. After that's running for a while, take another step. And after several months of, okay, we got a little bit here, a little bit there, a little bit there, build up our confidence in our ability to do this at a larger scale. Okay? So sometimes there's this, oh my God, I can't wait to do this on a big, gigantic project. Please, start small. Okay? Hope you've enjoyed this, and if you have questions, please come up and ask me. Thank you very much.